Hey grade 8s, welcome to your Friday math lesson. So this week you're not going to have a lesson on Monday because of the holiday. So that being said, enjoy your holiday, enjoy some time. I hear the weather's supposed to be really nice this weekend, so here's hoping. What we're going to do today is we're going to do a review of the algebra that we've been working on. And then we're also going to go into the next step. So we've done addition and subtraction and finding out what those letters stand for in algebraic problems. Now we're going to go into multiplication and division. So let's do a review first and foremost. So 5 plus b equals 12. We have to figure out what b is. So to do that, we do 12 minus, and we do the opposite operation. So we added 5 on this side. Instead of adding, we subtract it. So I take 12 minus 5. Okay? Because you always do the opposite operation. So 12 minus 5 gives me 7. So that means b is equal to 7. Because if I plug it into my problem, 5 plus 7, so if I get rid of this b and add a 7 in there, does it equal 12? Yes. And that's how I know I got it correct. On this side here, we have c minus 2 equals 14. So we have to figure out what c is. So to do this, I take 14 and I do the opposite of subtraction, which is addition. So I add the 2. And that gives me whatever c is. So 14 plus 2 equals 16. So therefore, 16 is equal to c. So if I plug that into my problem, 16 minus 2 equals 14. Is that correct? It is indeed. So that's our little bit of review. Today we're going to go into multiplication and division. Multiplication and division is a little bit different. For one, because you're dealing with different operations, and for two, you're used to seeing multiplication with an x and division with a little division symbol. In algebraic problems like these, usually they're represented a little bit different. So a multiplication problem will look something like this, like 5a equals 15. When there is a number and a letter right beside each other like this and there's no operation in there, there's technically an invisible multiplication symbol right in there. You just can't see it. Okay? So whenever it's just two numbers like this together, it means to multiply. Okay? Division also looks a little bit different because division will look like kind of like a fraction. What it will look like, it'll be like 15 divided by b equals 5. What that means here, it's not a fraction, it means division. So when you see something that looks like this, or if you see like, maybe not 13, you see something like 12 over 2, that means in this case, for the purposes of this unit and for these worksheets that you're going to be working on, it means division. Okay? So these mean divide. So for the purposes of this lesson, I'm going to write out the problems like I just showed you, so you can get used to just seeing them that way. And it's just good practice, just because, especially for multiplication, you'll continue to see that more often in the future. So let's do a couple of multiplication and division problems where we try to figure out what that letter means. So let's do our original problem that I showed you earlier. So we had 5a equals 15. So this means 5 times something equals 15. So it looks like this, 5 times 15. What does that a stand for? In order to do so, we have to apply the same rule that we did with addition and subtraction. We have to do the opposite operation. So what is the opposite of multiplication? The opposite of multiplication is division. So I have to take my big number, my 15, and I divide it. So I'm just going to show you division like this for just to get you used to seeing it that way. 15 divided by 5 is equal to whatever a is. So 15 divided by 5 equals 3. You can use a calculator for this, by the way. 3 equals a. So that means if I do 5 times 3, what's 5 times 3? 5, 10, 15. That means it works. Okay? Let's do one more multiplication, then we're going to do a couple of division problems. So now let's do 4m is equal to 28. We need to figure out what m is. To do so, we take our 28, our big number, and I divide it by 4. So again, I'm just showing you this way. Even though it looks like a fraction, I'm just showing it to you this way, just for the purposes of getting used to seeing it this way. So 28 divided by 4 is equal to whatever m is. Okay, so 28 divided by 4, I can punch that into a calculator and that gives me 7. So 7 is equal to m. How can I check to see if it's right? 4 times 7, does it equal 28? It does. So we're good. All right, so that's our multiplication. Now we're going to do a few examples of division problems. So let's do 15 over n equals 3. So we have to figure out what n is equal to. How can we do that? Well, with division, here's where it's a little bit different. So multiplication, we do the opposite operation, which is division. However, if we do the opposite of division and we multiply, so if I did 15 times 3, let's try it out. 15 times 3 is equal to 45. If I do 15 divided by 45, does that equal 3? No, it definitely does not. So in this case, I don't do the opposite operation. This is where division is also a little bit unique. What you do to find out what it is I take 15, I keep my 15 where it is, I put that line underneath it, but here's what I do is I take this n and I take this 3 and I switch them around. So I do 15 divided by 3, so I put that 3 down there. That is equal to n. Okay, so that's what you need to do. Your big number, it stays where it is, and you switch over. Because if you try to do the opposite operation, it wouldn't work. So 15 divided by 3, 15 divided by 3 is 5. So 5 is equal to n. Now to check to see if I'm correct, I do it the same way as normal. So I do 15, I plug in whatever my n is equal to, so I plug it in here. Does it equal 3? It does. So there we go. So this is where division's a little bit unique because you don't just do the opposite operation like we did with everything else. So let's do a couple more problems, just because I know this one is a little bit tricky. So let's do 28 over, let's not do that, 28 over m is equal to 7. So In this case, am I able to do my opposite operation? Can I just do 28 times 7? No, it would not work. What I do is I switch these two around. So I take 28 and I put it over 7. So I put my 7 and I bring it over here. And that is equal to m. 28 divided by 7 is 4. So therefore, m is equal to 4. So I'm going to plug that in. I'm just going to erase this so it looks a little bit nicer. So I do 28 divided by 4 is equal to 7. So I have to check 28 divided by 4. I can plug it into a calculator if I need to, or I can just review my times tables. Does it equal 7? It does. So that's how I know I'm right. So we're going to do one more problem before I send you off. Let's do 35 divided by e equals 7. So I need to figure out whatever e is equal to. I can't multiply them. I basically just switch these numbers around. So 35 divided by 7 is equal to e. 35 divided by 7 is 5. So therefore, e is equal to 5. I plug it in, so 35 over 5, because I plug in wherever my e was originally. Does it equal 7? It does. So we are good to go. One problem I just want to go over. What if there is a variable on top? So you might see a couple problems like this where you have, let's say this is p over 5 equals 7. What do you do in this case? I can't just switch these up because I can't do 7 divided by 5. It wouldn't work because it would create a decimal number. These need to be whole numbers. So this is another rule that we're talking about. So if the letter is on the bottom, you need to divide. You switch it up and you divide. If the letter is on top, you actually need to multiply. See, this is where division gets tricky, because if I divide, I get a decimal number and it wouldn't work. I need to have a whole number on top. So what do? Is I keep the p on this side of the equal sign, but what I do is I take this 5 and I move it over and it becomes multiplication. So it becomes 5 times 7. So now I have p is equal to, what's 5 times 7? 35. All right, let's do one more problem that has the variable on top. The variable is the letter. We're going to do one more. That's an O, by the way, not a 0. O over 9 is equal to is equal to 7. So in order to do this, I have to keep my O on this side of the equal sign, and I move this 9 over, and it becomes 9 times 7 instead of dividing. So O equals 9 times 7. O is equal, what's 9 times 7? You can use your fingers or a calculator. It is equal to 63. So that means when I plug in my number, I take my original problem, I do 63 over 9. 63 divided by 9, does it equal 7? It does. So there you go. So remember, if the variable is on top of that fraction looking thing, the variable's on top, you need to multiply your two numbers. If it's on the bottom, you have to switch them and divide. Okay? But that's it. And I will see you guys on Wednesday. Be sure to email me if you have any questions whatsoever. And otherwise, I will see you guys on Wednesday. Have a fantastic weekend. Hopefully, you can enjoy some of this nice weather that we're supposed to have. All right, see you guys.